Welcome back, generals, to another Let's Fix Generals 0 hour to make the best game ever. Good. Yeah, so last session we did do some performance investigation and optimizations. There still was a question about this 32 here. Should there be this value or not? Tiles of side length. Maybe. Border size in line. Maybe. Overhang. Cast array. Return intersection of array with a height map mesh. This is a quick version that just checks every polygon inside a 2D bounding rectangle of the array projected onto the height field plane. For most of our view picking cases, the array is almost perpendicular height field plane to the map plane. So this is a very quick small bounding box. Or you can do array cast. And how do we get the results? Contact point. Is it being hit? It's a bit strange that it doesn't return the hit point. It only says I have hit. It doesn't tell us the point of it. That's strange. $32. Face height map. It also includes world height map, so this one does have access to this. Okay, how about I put it in here and hope it makes sense. Yeah. Okay, good. Then next step, let's. So we took a note that we want to optimize these two calls here. Yeah. Get your vdate. Get your vdate. Okay, what does this function do? This function does quite a bit. Don't show the texture for debug. Ugh. Well, there's quite a bit of get your E for tile index. Okay. Get UV for tile index. Oof. Boah, that's quite a big function. Oh, dang. Just cliff textures. Okay. How do we do it? Map X, map Y, UV. UV half res mesh. False. Full time. This half res mesh, what is this? Is this? Oh, it's never changed. Okay. Okay, let's mix. That helps. Const expr. Can it actually be const expr here? I think so. Okay, yes, let's use const expr for all these first. That's simple enough. We'll eliminate some conditions. It doesn't have VC6, but who cares? Ugh. Ugh. Damn. Okay, is that it? Yeah. Let's see if that compiles. Use const expr around half smash. Okay, and then next we do so basically we need a function to compute this. Compute index draw origin, index draw origin, x index, x map x with origin, x. Okay. Get UV for turn next. Okay, I think the first step is to pre-compute this one here. full tile. Boah. So there is a qualifier here, full tile. I'm not sure how I deal with this one. Ah, but this one is const expr. Well, that helps. Why do we pass it then? Full tile. Is this a virtual function? No. So we need to pre-compute this shit here. This first. Get UV for tile index. The only question is there any data in here that changes? Maybe. Cliff info. The world height map. I assume it is static. Set cell cliff flag. Except in world builder, there wouldn't be. World height map. UV data. I wonder, is this function also called in world builder? flip for blend. That's an in out. Okay. V for tile index. Okay, how about we add a new function here? Void compute UV for tile indices. Then we do a full tile. Okay, and then down here we add a new function here, world height map. Good, and then in here we would now have to go through, how's this working? NDX, data size. So looks like we just go through all this data NDX. Blended tiles, blend index. Okay, let's start simple. So we do a for, what is this data type? Int print ndx equals 0, ndx smaller than data size plus ndx, and then what is this? And tile indexes. What is this? Tile indexes. Okay. Save. Return. Good. Then we have this short. Return false. Why does it return false there? if blend NDX is null. Wi-Fi data. GOV for tile index. Not sure. So if there's two different things here. Oh, I still need to fully understand this shit here. Get UV data. Okay, this one is simple enough. Tile index. I think we need to do this thing here. So here we have extra blends. So const short tile index. So then we have this one, tile index. Just use that. Okay. Okay, so we have that, and then we also have this guy. Then we also have this guy, but with extra blended indexes. No? Blended tiles? Extra blended tiles. There we go. It also uses blended tiles. Okay. Okay, and then we basically need to do things in there, right? So we say if it's quite a bit heavy. Why don't we just call why don't we just call these established functions for it instead of writing them again? But then so maybe instead of doing all this bullshit, we do get alpha UV data and get UV data and get extra alpha UV data, and then in here we call I think we take map, get probably this width heights, I think. So we build a new loop for int x 0 x smaller than width plus x. I think the looping was always done with y first, right? So maybe we do the same thing here, right? Maybe that's more cache friendly. Yeah, width. Okay, and then we take these things. Okay. And then compute UV data. Let's call this pre-compute UV data. Okay, and then here we say x, y. So here we have this guy. U, UV, and full tile. And the return. The return was the return is not used. What is the return? I don't know. It turns true if the textures has to be stretched for cliffs. Stretched for cliffs. I can't jump into this function here for some reason. Cliff. Good. Then here we say Bool stretched for cliff. Okay, so this is all the information we get here. Then the next one would be alpha Bool full time. Alpha. Oh, get alpha UV data. What is this? Flip for blend alpha. Okay. Flip for blend. Okay, UV flip for blend alpha. Good. Then here also we pass X, Y, U, V, alpha, flip, and full time. Okay. And then the last one. The last one is X, Y, U, V, alpha, same flip for tie blends, and cliff, stretched for cliff. Let me take this. Okay, cool. So these are the information that we get out of this. Okay, and then we need to. So let's comment all this here out. Don't need that anymore. So and now we need to create arrays for these and lay them out. So let me move this function. What is it called? Pre-compute UV data. Let's move it to this public. So init pre-compute protected. Let's move it here to the top, okay? For now. Okay, let's take this function and let's move it. Let's move it up here. Right, so then let me see other places that loop. Yeah, it starts looping at Y. Ah, look, this one is also grabbing it, yeah. Generate lookup table for determining triangle order. Lookup table. Lookup table for determining triangle order. Get terrain texture. So it only goes to -1. Why that? Init cliff flags from heights. Okay, so it looks like it always iterates to width height -1. Okay, maybe we just use the same style. Okay. Then that's looking good. The next we do so we need some arrays. Here. Seismic. Texture indices. Let's just put it here at the bottom. Yeah. So let's call it. Let's make a struct. Struct. Struct UV data UV data. Then we add a UV UV data cache. Then we have an alpha UV data. Then we take this here. Call it alpha UV. Alpha UV data cache. How do we type it? Alpha UV data cache. Then we call this UV data cache. This one is the extra alpha. Extra alpha UV data cache. And there we have these guys. Good. Then here we call delete. This one deletes and deletes. Then we allocate these guys. So that will be this new new does it use any special things for allocation data? Message new. We should do that as well. Message new. UV data cache. And we put a width times height. Is that correct? Same texture classes. Data size. Okay. What is data size? Width time height. Okay. Interesting that they have it in a separate variable. Okay. So UV data cache. UV data. UV data. Good, and then we do the same for the other guys. Alpha, extra alpha, and this is alpha and extra alpha. Good, so this is the allocation event, and then here we do I think what we can do is simply this guy. How do we access it? Tags. Plus J I times new width times new width. So that should be I times X index times width plus Y index, right? Good, and that would be UV data then here we pass data U, data V, and data stretched for cliff. There we go. Don't do the same here for the alpha UV data cache. Alpha UV data and okay, and the next one extra alpha data extra alpha blah 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 data and so on. Good. So this should now pre-cache all the shit. Yeah. Okay. Now we also need to put this at some clever state after the textures are loaded. How do we do that? What is the init function doing? Simple constructor. We also need to initialize. Hold on. Okay, I might take these guys here and initialize them to num. Good. Good. So now the question is, at which point can we actually Set up alpha tiles. When are the textures loaded? So here it already parses the stuff. Does it have like an init function or something like that? Destroy. Protected. So it is being constructed here with the terrain height data, but when are the images loaded? I don't know. Can someone tell us where, how this thing's, where's this created? Let's see that. Init height data. This one gets it passed already. Oh, who is creating the world height map? Here, client and logic height map. Render object building. Okay, how about we put a breakpoint in there and just see who calls the constructor. And if we see from there, because right now I have no clue where the party starts. Where's the constructor? Here. So it should be calling this one, right? Good. Let's see if it compiles. Yeah. Let's see who is calling this. Good. So, Caustic, load map. Terrain height map, get all boundaries, blah, blah, blah. Huh. It will release it here. Release temporary object. Huh. Why is it released here? That's weird. Is it created twice? It is. Terrain visual also creates one. Logic height map. Why do we have two? Okay, let's do it again. So it's being created twice. And one time it's thrown away. Oh, that's weird. Why is it doing that? Yeah, so this one is reading the height map, then it has it allocated, and then it does something here, And then it will step down here, and then here it will delete it. Right? Hello? Total refs. Deck total. Yeah. Num refs, yeah. And now it will call delete this, and it will delete it. There we go. And it has deleted it. Yeah. Okay, that's weird. Okay, and the second one is being called here, but this one is kept. Logic height map is kept. Okay. So what will be done with the logic height map? Init height data. Logic height map. Init height data. So at this point, what do we have in here already? Do we have any texture information already? Texture classes. There's something here. Looks empty. No. The question is like, when is the texture computed then? Do we know? Edge terrain text. To me, it looks like there's nothing happened yet. Let me search for terrain text. Terrain text. Who is creating this? World height map. Terrain text. Yeah. Here, get terrain texture, which has a lazy initialization. I see. Okay. So who is calling this? And do we actually need it? I think we do. Planet tiles. Or do we not? Well, it's a question now. Do we need the texture information or not? Or is everything ready already? That's a question. No, here it accesses texture classes. Yeah, we need that. Yeah. So it should happen after texture pass, earliest. Maybe there's still some other stuff that needs to come later. So who's calling this? Get terrain texture. Update block. not sure. How about we do the following? Init height data, what does this do? This one will read from the map, right? Map. So we need to... How about we just test what happens here? So we have logic height map, and then we just pre-compute. Seems to be private. Right. Let's make it public. Let's put it here. Pre-compute full tile. Pre-compute UV data. Now the question is, do we have access to this thing here, half res mesh? Half res mesh. We don't. How do we get hands on this? It's in height map CPP. Okay, then maybe we need to put it into the init height map. In here, maybe base height map. Base height. It's a virtual function. So maybe in here we call tmap. Pre-compute UV data. Okay, let's put a breakpoint here and let's see what happens when we do that. I suspect it will crash because of some null pointer dereference. Okay. By the way, before I forget it, we also need to delete these guys in the destructor. Here, world height map. Delete. There we go. Let's try this again. Yeah, the only problem is I think this is actually already too late in a tight data. Yeah, for now it's okay. It needs to be moved somewhere else. Yeah. Good. Okay, there we go. And oh, it didn't crash. Well, that's surprising. Okay, it did actually compute things. Interesting. Let's step into it and see what it does. Good. So full tile is false. Full tile. I'm wondering. Is this actually correct here? It says full tile. And we pass half res mesh, which is false. So shouldn't this be negated, not half res mesh? I'm confused. Maybe it's wrong. sure. Should half res be flipped? Question mark. We'll check it later. Good. So there we go. Good. Half res mesh. Pre-compute UV data. Full tile. So yeah, let's jump into it again and see what it does in terms of texture. Okay, good. So, okay, data, blah. 0 times that. Good. So we jump in here and then draw origin. What is this? Draw origin. It's weird that they add the draw origin there. X index. X index and Y index are the integer coordinates into the height map. Full tile is true if we are doing half resolution height map. Ah. But why is it called full tile then? Half resolution height map. Require a full tile to texture a cell. Otherwise we use quarter tiles. Huh. Okay, then maybe it's correct. Okay, I'm a bit suspicious about this here. Why is it adding draw origin X and draw origin Y? What is this? That's weird. Draw origin. Probably need to. Yeah, this looks weird. This looks extremely weird. Yeah. Why is it doing that? Get UV data. Get X with origin. This stresses me here, this shit. It looks like it doesn't belong in here. Because it makes some assumption about the caller having this offset somehow. Like, what is this? How does this make sense? Are there any other functions that take coordinates? This one. Draw origin also does it. X, Y. They all do it. Huh. This one doesn't. This one takes literal index that we pass. And normal coordinates. See. This one uses special offset. I see. That sucks. So they have like two coordinates. This one. I see. Well, that's confusing. Maybe what we should do is so they have a naming convention, X index, and then they have XY, don't they? Maybe. It looks like they use two different kind of coordinates, but they don't use anything that indicates what coordinate this is. Oh, that sucks. That really sucks. Okay, how about we move this function here, and then we move these two up here. And then we do get So the problem I have with this shit is that they put in here coordinates and there's no telling what these coordinates are. That's really bad. This one doesn't do. This one uses normal coordinates. Look at that. Yeah. Interesting. So this one uses... This one also uses special coordinates. Yeah. But this one does not. This one uses regular coordinates. Okay, that's extra confusing. Get extra alpha UV data. Okay, we need to somehow solve this. This is not pleasant. The question is how. Okay, it's only called at one place. That helps. And this one is called at multiple places. Okay, but then this call is wrong here. The fuck is this bullshit? Only works by chance. Ugh. So it's made for this call, for these coordinates here. X with origin. This one is compiled out. They seriously screwed this up. Don't they? KJ. For the breakpoint here. Minus get draw awk. Aha, here it cancels it out. Look at that. This is how it should be done. Okay, so I think the way we fix it is here we have to do plus draw awk. Okay, that's step number one. Then in here, get UV data. Let's stop debugging. In here, we remove this. And here as well. And here as well. And that's it. Yeah, okay. And then we go back to this one, and now we need to treat all these guys here. So here we delete this. This one I think is already correct. Yeah. And then this one is now also correct. How about we rename this to X, X, Y. Keep it short. Okay. Now the question is, well, this one is compiled out, patch origin. Then we just leave it for now. Yeah. What about this one? Row start. Yeah, I don't know about this one here. That's weird. Well, we will see. If there's a bug, then one of these chords is incorrect. Yeah. Okay, it calls it multiple times. Okay, things still look normal. Yeah. Crash. Okay, they don't look normal. Get UV for tile next. Okay, let's see. What is a call stack? Pre-compute X, Y with X. Pre-compute. Okay, I don't know why this crashes now, but obviously that's not good. Okay, it's also not correct that it calls this thing like so many times. But that's not important right now. Okay, so why is it crashing? I don't know. I think I would take a break here. Good. Take a break. I wish you a great day or night. Until next time. Goodbye.